Hello, thanks a lot to the organizers for having me here and allowing me to present updates about Snakemake. So for those who do not know what Snakemake is a workflow management system that is very successful with a lot of downloads, a lot of citations, and used by many high-impact projects like Genome in a Bottle and NextStrain, a lot of high-impact publications, and so on. The key idea of Snakemake is that you define a data analysis workflow in terms of rules, and each of these rules models a step in the analysis, things like aggregation, transformation, filtration, the generation of plots, the application of tools, and so on. So basically everything from the raw data to the final results that are published in a paper or sent to collaborators or whatever. And in Snakemake, these so-called rules are defined in a text-based language. So it's a workflow management system that you program with a domain-specific programming language. And this language is, in fact, an extension of Python, which means that apart from these rule constructs that allow you to model the steps, you have the full power of Python to do anything you want. And that makes Snakemake a very powerful system that at the same time allows very readable workflow definitions, because these steps are like designed to be human readable without a lot of programming knowledge. Okay, dependencies between these steps or rules are determined automatically by Snakemake by matching input files against output files. And by that, it obtains a directed acyclic graph of jobs like you see here on the right side. Now, of course, talking about data analysis and workflow management, everybody thinks about reproducibility. And that's, of course, that has been, of course, like the holy grail in the field. Everybody wanted to achieve that. And this is what people usually strive for. And of course, reproducibility gives you a lot, like the ability to check whether results are valid from a technologically or technical point of view, in the sense that you can generate exactly the same results as somebody else before, for example, like regenerate results from a paper or whatever. And that is, of course, a high value that one should definitely strive for. However, thinking about what this gives you, it does not give you everything needed for checking whether a data analysis is valid. Beyond reproducibility, one should additionally look at other aspects, and these are adaptability and transparency. In particular, transparency will give you the ability to check a data analysis from a methodological point of view, so whether the methods used in the analysis are actually valid. And with transparency, I mean there the ability to zoom into a data analysis and look into specific aspects of it, how certain plots are generated, and so on. So that's an important goal as well. And another important goal is adaptability. And with that, I mean the ability to take a data analysis that somebody else has published and use or reuse parts of it or the entire thing for new research questions. And these three aspects are equally important, I think. Not only reproducibility is important, but the other two as well, because only with the other two in combination, you get something that is a sustained value of a data analysis, so that it really has some impact on the field, not only for a single publication, but some value beyond a single publication. So these aspects are driven by several properties like automation, scalability, and portability, which are all provided by Snakemake, and adaptability is driven by scalability and portability as well, of course, because if you cannot scale and port a data analysis to a new system, you also cannot adapt it to your own needs or to a new research question. And then very important for adaptability is the ability to actually read and understand the analysis. And this is what Snakemake particularly strives for with its domain-specific language for workflow definition. And transparency is additionally driven by the ability to trace things like parameters and software tools used and documentation of all the steps. And only when considering all these aspects together, you really get a data analysis that is of sustained value for your field. Okay, and I show you this because this has been like the blueprint for developing Snakemake in the recent years. So we basically wanted the system to shine in all of these aspects and to make all of these aspects as easily achievable as possible. And today I will show you some of the improvements that led to these abilities in Snakemake, and allow Snakemake to provide all this to you. Okay, so the most important thing comes first. In terms of adaptability, Snakemake has recently gained a new syntactical feature that allows you to easily compose workflows together and reuse existing workflows. And this is Snakemake's new module system. And the key idea is that you get an additional syntax to declare so-called modules. And these modules basically always refer to some kind of snake file, which is like the central entry point of a Snakemake workflow. And that can be given by a local path to another workflow or by a URL to a workflow that is published on GitHub or so. And once you have declared an external workflow as a module like this, you can, in your current workflow, use or reuse the rules from this external module by the syntax you see here below. So there's this use rule statement, which takes all the rules from the defined module above. And by this pattern, you can basically easily compose any kind of workflow together and extend it in any way. So let me show you how that works. For example, we can, in this case, take a particular rule from the module, apart from all the other rules that we have imported before. And upon importing it, we actually modify it in the sense that we override the given parameters in the external module by some additional property, for example. And this allows us to not only reuse existing workflows, but at the same time modify them according to our new needs. In terms of adaptability, that's of course very important. And this modification becomes very transparent because everybody immediately sees, okay, this workflow was used, and then the following things were modified. So that's, again, not only adaptability, but also transparency at the same time. So let's have a look at a more complex example. We can also use the module system to combine different kinds of data analysis to, for example, obtain some kind of integrative analysis. Concretely, for bioinformatics, let's assume we have some DNA-seq and RNA-seq experiments for both. There are probably properly written Snakemake workflows already available in the internet, like on GitHub. We have the RNA-seq Callisto workflow, and we have a DNA-seq workflow using GATK. And we can define these two workflows as modules, like you see here. And since, of course, both of them need some kind of configuration, we, in this case, use a common big configuration file, combining the two configurations in separate subsections, and we pass on the specific configurations for each of the workflows as subsections of our global configuration file here. And then we tell Snakemake to use all the rules from the two modules here. And that's already it. So now we have already combined two workflows. But of course, that would be of little use if we couldn't also like really integrate over the two. And here it comes in handy that this module system, of course, blends nicely with Snakemake's ability to define additional rules. So we can, of course, define any kind of additional rules here below, something that takes maybe the results of the two workflows, integrates them in some kind of plot that maybe highlights the integrative results and so on. And of course, that's not limited to a single rule, that can be multiple rules. And of course, you can modify the rules that you take from these two workflow modules here upon importing them here, as you've seen before. Okay, so the same module system has an additional benefit apart from just composing new analysis together from existing workflows. And this is deployment of workflows, which has traditionally in Snakemake been a matter of like cloning a GitHub repository to a local system or GitLab repository, and then just modifying it according to your needs and apply it to your new data. The problem with that is that you always get a copy of the code, which is redundant, and it's hard to track changes from the upstream workflow and so on. So the new deployment method of Snakemake relies on the module system as well. And for that, we have made a helper tool called snake_deploy, which has a subcommand deploy workflow. And this subcommand just takes a URL to the published workflow, for example, on GitHub, together with a release tag and a path where to deploy it. In this case, it's like just the current directory visualized by this dot here. And then what this tool will actually generate for you is the structure you see here below. So first, it copies all the template configuration from the published workflow so that you get a nicely pre-configured thing where you just need to change values and insert samples and so on. And additionally, it generates just a single snake file, which just points to this external workflow as a module. So let's have a look. So the snake file just looks like this. It just declares the external workflow as a module here. So thereby the deployment basically just works via the module, and it takes all the rules from that external module. That's it already. So what is particularly nice about this is that, again, this enables you to later on extend upon this. So first you have just a deployment of that existing workflow and can just adapt the configuration. But later on, you might feel like adding additional plots, modifying the existing steps of the workflow, and so on. And of course, below these statements here, you're free to do all of this. And thereby, all the changes that you make to this existing workflow become entirely transparent. And of course, you can also go and take another workflow and integrate it with this one, and so on. So this becomes really nicely adaptable. Okay. Together with this new deployment method, Snakemake has also now a catalog of available workflows on GitHub, which is automatically scraped from all the available GitHub repositories, all the public GitHub repositories. And this catalog just shows you all of the workflows together with descriptions and so on. And we also try to give you some kind of quality control information like the license, last commit, and linting and formatting. So Snakemake has a built-in linter and a built-in formatting method, so to ensure code quality and readability. And these are checked automatically in this catalog. Okay, so apart from this just scraping and cataloging all the available workflows, the workflow catalog additionally provides a category called standardized usage. And if we go there, we see that the workflows here have an additional button here upon hovering them, which allows us to show some usage information. So again, you see the meta information about the workflow, and then you see steps like step 1, install Snakemake, step 2, deploy the workflow with snake deploy, then configure the workflow, run the workflow, and generate a report with all the results in it. And all this document here is rendered automatically from the scraped repository by just following some standards. So if a repository follows certain standards, the Snakemake workflow catalog will automatically generate this, and each workflow in this category here, in the standardized usage category, has the same installation and usage instructions. And this configuration instructions are, of course, rendered then from a separate README file. Okay. So the goal of this is, of course, to simplify the usage of Snakemake workflows in the sense that you always use them in the very same way. And we strive to gradually convert all public workflows over to this new pattern to make it very simple and easily composable and easily adaptable. Okay. Next topic is portability. So Snakemake has always been strong in supporting Conda as a way of annotating software dependencies inside of your workflow. So as you know, or probably know, it's possible to annotate each rule in a Snakemake workflow with a Conda environment, as you see here. And this environment then basically just lists the software needed for the particular step. While this is nice and Conda is very ad hoc and easy to use and also easy to deploy on new system, it has some drawbacks, and that is that you basically just define a shallow stack of software on top of the existing operating system, which in some sense can have an impact on reproducibility. So usually it shouldn't, but there might be corner cases where where the operating system might also have an influence on the results generated on such a Conda software stack. And additionally, depending on the operating system, the version of system libraries, and so on, there can be sometimes issues when deploying Conda environments, especially if you switch from macOS to Linux or vice versa. So therefore, of course, you all know that containers are a nice alternative because they fix down to the operating system, basically everything except the kernel. And if you switch between systems, even the kernel. And these containers allow you to get a bit more robustness, but the downside of using containers is, of course, that they have much more overhead. You need to define the Docker files, you need to build it, upload it to registries, and so on. So that's not nice for development, where you quickly have to change tools, versions, add certain libraries, and so on. And always rebuilding a Docker file or many Docker files can be cumbersome and also a waste of resources. Therefore, Snakemake nowadays supports a concept that I call automatic containerization, which basically means that you can use all the benefits of Conda in terms of quickly defining a software stack that is actually needed for a particular step, being very transparent about this because these YAML files are much more human readable than a Docker file definition. And then upon release of your workflow, you can automatically containerize this into one like frozen snapshot of all the Conda environments. And this containerized Docker file can be generated automatically by Snakemake. So basically Snakemake takes the workflow, retrieves all the Conda environments, and records them inside of a Docker file that is generated by Snakemake. So first it adds the Conda environments into the container image, also displaying them as a comment here so that you also can read them as a human being. And in the end, Snakemake automatically creates the respective Conda environments inside of the container. And then you can use that Docker file, build it, upload it to a registry, and upon release of your workflow, refer to that container image from inside of your workflow, and thereby allow people to use the workflow with a respective container runtime and using that container image, which contains all the Conda environments. So the Conda environments will be used by Snakemake from within the container. So basically you get exactly the same as with Conda, just you additionally fix the operating system stack below. And this containerization image can be defined inside of the workflow by a new directive containerized, which just refers to the image, and then Snakemake can use it automatically for you. Okay, next topic, scalability. So Snakemake, since about a year, I would say, has a new scheduling algorithm, which I won't describe in detail now, but with just one very important property of that algorithm is that it handles specifically temporary files. So with Snakemake, it's possible to mark output files as temporary. And of course, these files you don't want to have on disk longer than necessary. And for that purpose, Snakemake allows you to consider this particularly during the scheduling. So basically, the scheduler has three maximization terms. The first one maximizes job priority. The second one maximizes parallelization, and the third one minimizes the lifetime of temporary files. So by that, whenever a Snakemake workflow is executed, regardless of whether it's executed on a local system or on a cluster system or in the cloud, it will strive to schedule jobs in a way such that temporary files are deleted as soon as possible. Okay, and this is like technically, this is a mixed integer linear program. Okay. Next topic is runtime. So we have also worked hard to improve the runtime of performance of Snakemake. You might have experienced that Snakemake had been slow before with very large workflows with hundreds of thousands of jobs. And this has been improved dramatically by orders of magnitude. Basically, we made the runtime linear in the number of jobs again, and also the memory requirement is linear in the number of jobs again. And that will give you dramatic speed improvements. Nevertheless, there might still be workflows which are very large. And since Snakemake has to check file modification dates and performs a pre-computation of the entire deck and not just starts greedily during the workflow execution, it always needs some kind of startup time, right? Especially if you're on a shared file system where you need to check modification dates, and that might be slower. This can be an issue for extremely large workflows. And therefore, we have added an additional functionality called batching of workflows. So basically, it's now possible to divide workflow executions into batches by defining such a batch command line flag here, which takes a rule name, which should be something like the central hub rule in your workflow, and basically a batch number and the total number of batches. And by that, you can tell Snakemake to only execute a first, a second, a third, a fourth, and so on batch of your workflow, which means, of course, much less jobs, much less dependencies and file modification dates to evaluate, and therefore a quicker startup time. And second, it's also always advisable to split large workflows into batches because it's also easing the maintenance, the job sitting, and so on, because you don't need to track thousands or 100,000s or millions of jobs at the same time. It can run in smaller pieces until you're sure that one piece conducted properly, and then move on to the next piece and so on. So this will allow you to scale the system up to any number of jobs, basically. Okay. So next topic is caching between workflows. So you will probably know that Snakemake, of course, always avoids redundancy. So when you restart a workflow, it will not recompute stuff that it doesn't need to. This is default behavior of Snakemake. However, there's a certain corner case which was so far as I know, also not covered by other systems and also not by Snakemake. And this is when you think about the origin of data going into analysis. So usually you have things like project-specific data, like the data sets of your project, the samples, and so on. But often there's also some kind of shared data, which is things like reference databases, genomes, SNP databases, and so on. So the problem with this shared data is that it usually also needs some kind of post-processing before you use it, like creating indices on top of it and so on. However, although these steps are always basically the same, you usually don't want to encode them in your data analysis workflow, because then you would waste a lot of disk space and also computation time in recomputing this every time you apply a certain workflow to a new set of data, a set of samples or whatever, always using the same shared data, like the same reference genome or something like that. So therefore, people have traditionally used like workarounds for this, like directories where they store reference genomes institute-wide or group-wide, or reference managers like RefGenie or GGD and so on. The problem is that these things quickly become black boxes. They are not part of the data analysis description, and thereby you lose transparency and also in some sense reproducibility, because you always need to define or tell the user about additional steps you did for generating, I don't know, the index, downloading the reference genome, modifying certain databases, and so on. So it's desirable to include the obtaining and post-processing of such shared data in the workflow, but of course you don't want to lose the performance and don't want to have all this redundant computation and storage. So what Snakemake now does to overcome this issue is that it allows you to cache results between workflows, so not inside of a workflow that you re-execute, where you, of course, do not repeat jobs that you don't need to, but even between workflows, between users, and so on. So the key idea of that mechanism is that Snakemake can now hash all the information about a certain job inside of a workflow in terms of the code of the job, the parameters used for the job, and the software stack used for the job. And Snakemake can do that for single jobs. It can also consider input files, like raw input files inside into this hash here. And it can use that to combine hashes of jobs. So for example, if you have an intermediate job that takes the input of two other jobs and computes something new about from this, the hashes of the input jobs will be included and considered for the hash of the intermediate job. Okay, so by that, any kind of job inside of a Snakemake workflow definition can be used to generate a hash that uniquely describes what exactly would be kind of obtained here in terms of what kind of output file would be obtained. And this hash description can be used to look up in a cache whether that exact result was already computed before. And if that's the case, Snakemake can just reuse that result from that cache. And this is an optional behavior, so that cache can be defined like group-wide, institute-wide, cluster-wide, or whatever, with the correct permissions, of course. And then people can reuse results from that cache. And things that come up often can be annotated inside of the workflow as being eligible for the caching. So of course, that does not happen by default, but it only happens on request. So for example, you can mark things like generating a BWA index or downloading a reference genome from NCBI or Ensemble or so. You can mark these steps as being eligible for caching, and then Snakemake will never do these things twice, but instead just take that from the cache if somebody else has already generated that file. Okay, and this is not relying on file names or so. So the workflows can use completely different file names, but if the hash is the same in terms of code, software stack parameters, it will still find the correct result inside of the cache. Okay, so the nice thing about this is, of course, that you can include all this shared data obtaining and post-processing step into your workflow, making it very transparent and easily portable to a new system without additional setup steps needed, basically. And that's, of course, desirable. Okay, another feature about scalability is DAG partitioning. So Snakemake is able to partition a DAG of jobs into larger groups and thereby save queuing time on a cluster, for example, or save disk space or avoid network I/O in the cloud and so on. And this partitioning mechanism has been extended recently by a command line interface, which allows us now to assign jobs to groups via the command line. So in this case, the group would be the group A here, and we assign the two jobs, select by country and plot histogram, to that group A. And by default, this group always only spans a single connected component. So you see that the same group occurs several times, always connecting to like the two jobs, select by country and plot histogram here. So we get many groups of the same form. But additionally, you can now define whether the group shall span multiple connected components. This works via the group components argument here. So for example, if we specify two connected components for the group A, it would become larger here, as you see here. And of course, if defining more, it would at some point cover all the jobs from the two rules, okay? So you can imagine that this is a very powerful tool to define any kind of partitioning for your execution in a cluster or a cloud. And of course, yeah, so that gives you a lot of possibilities in scaling up a workflow and making maximum use of the available resources. Okay, so next topic is automation. Snakemake has gained integration with Jupyter notebooks. So it has always been strong in integrating scripting languages, as you might know. So there has been the script directive that allowed you to refer to an external script. And by that, add plots and transformations and filtrations to your workflow in a very ad hoc fashion. So not needing a lot of boilerplate code in the sense that you need to write a new external script with a boilerplate for command line argument parsing and so on. But instead, the script was directly integrated into Snakemake so that you can, from the script, immediately access input and output files and other properties of the rule. However, the scripting always meant that you need to run the workflow with the script until you're happy multiple times, maybe iteratively improving the script and so on. And that was, of course, working, but it had, of course, some downside because it was not so interactive as it would have been with Jupyter Notebook. And therefore, Snakemake now integrates with Jupyter Notebooks, which basically allow you to interactively encode certain steps or code certain steps until you're happy, and then use the notebook in a batch mode inside of your workflow. So how does that work? Let's have a look at a short video. So we define a Snakemake workflow here with a single rule, in this case, just a hello world rule that generates one output file. We define the output file here, we define a conda environment for that rule, and we define a notebook for that rule. And that notebook does not need to exist. We just specify a path to that notebook, okay? And then we store that file and we quickly generate the respective conda environment, define the channels, just the conda forge channel here. And the dependencies, like the packages inside of the environment. And this is just, in this case, the Jupyter package. Okay, so of course we could add other libraries there as well. And then we run Snakemake with use conda with a single core, and we tell it to edit the notebook that we just defined as a single path by specifying the corresponding output file. And then Snakemake will automatically open the notebook for you and draft it in the sense that it will add some kind of preamble containing basically the properties of the job, input and output files, and so on. And now inside of the Jupyter Notebook server that we see here on the left side, we can interactively code whatever we want to do in the notebook until we are happy. So you can see that we can directly access the output file here. This is basically done via the preamble of Snakemake here. And now we write hello world to that output file. And once we're happy with whatever the notebook does, of course, we can interactively run it now until we are happy, generate plots and so on. We can save it, we can close the notebook and quit the notebook server. And you'll see on the right side that Snakemake has recognized that and that the notebook is now stored inside of the working directory of the workflow where we specified it to be. So along with our other code. And next time we run the workflow, Snakemake can just reuse the existing notebook, and we don't need to interactively run it anymore. It will just basically use it in batch mode. So you can basically draft the notebook interactively for one sample or whatever, one combination of parameters, and reuse it later on. And of course, you can at any point decide to rerun your notebook and edit it again and refine it and so on. Okay, so next topic I want to quickly talk about is transparency. So Snakemake always has had strong reporting functionalities, which have in recent years been further extended and improved. So this is how Snakemake reports now look like. So you first get a visualization of the dependency graph. You get statistics about all the rules and the runtimes and when output files were generated. You can immediately and automatically see the configuration file of your workflow. And if annotated accordingly, all the results of the workflow can be included into these reports. So you see basically for each result file, you see like a table entry. If it's a graphical file, you see a preview of the graphics. You can download the original, and you can look at all the provenance information about the generated result, like for example, wildcards, parameters, and even information about the rule itself in terms of software input files, output files, and even the code used to generate the plot or whatever. Okay, so I see this like a supplementary file 2.0, which should be like added to any paper that is published, in the sense that you not only have a methods section with text written down, but in addition, you have like something like an interactive supplement where you can find again all the plots and see them along with the actual code generating a lot of transparency. And the descriptions you see here are templated, so you can, in a production workflow, like as a core facility or so, you can design them to react on things like parameter choices, configuration values, and so on, and display different text here dynamically. Okay, finally, some words about readability. So we have already seen like the rules of Snakemake are of course designed to be particularly readable. Nevertheless, it's possible to make them completely unreadable, of course, as you can do any kind of Python magic around it. And one has to be careful with that because readability of a workflow is the most important thing to strive for. That is even more important than maintainability, because the data analysis should always be transparent and understandable for others. That's the most important thing for data analysis. So Snakemake has added some tooling to increase this readability and to help people with reaching it. And here, first of all, we have a linter now with Snakemake --lint. You can lint any workflow and get information about things that could be improved, always with referring to the docs, for rules, for the entire Snake file, and so on. And in addition, Snakemake has a formatter that automatically formats your workflow according to the best practices in both Python and Snakemake itself, which is the Snake format tool that can be installed additionally to Snakemake. And yeah, so basically it takes paths to Snake files and will automatically reformat them according to the standards. So to bring this to an end, we have also published a new paper about Snakemake earlier this year. It's published on F1000, and the reason for that is that it's meant to be a rolling paper. So we will update this paper whenever Snakemake receives a new feature, and it's really meant as a comprehensive overview about all the features of Snakemake, also in terms of these properties and aspects that a data analysis should strive for. And it will give you a high-level overview over everything, also providing design patterns and things like that. So I strongly recommend to give this a read, and this will also repeat several aspects that I've presented in this talk. Thank you. Now I'm happy to take your questions.